you from the 2 last exams to kind of highlight a few of the questions that I've seen in the past problems and that seem to occur over and over. So I'll kind of let you know where they are so you can follow along, and maybe you've done these before, but at least you know to make sure you do understand them, because I have seen these types of problems over and over. For the first one I'm going to go through is it's book 2 of January 2019. So it's the purple book, book 2, and it's question number 43. And I'm going to use kind of an order here. So if you look at question 43, it says, given the graph of f of x, sketch the graph of the absolute value. I'm going to do a couple of these questions in a row. Now, part of your curriculum was, given a graph, you should be able to sketch the absolute value. Another thing that they ask you is sketch the square root, right? And the next exam, it asks you to sketch the square root of a given graph. So we'll do that one next. But notice they give you a graph, and then right underneath they give you the same graph, just in dotted line. And they always have a little caption that says, the graph of f of x has already been re-sketched for you for your reference. So they're just getting you to look at this one. It's the duplicate graph. They want you to do your work here. So they say sketch the absolute value of f negative x. So there's 2 things going on here. Do you agree? Given f of x, they're asking me to do 2 transformations. The 2 transformations are a reflection. All the x's become their opposite, so reflection over the y-axis, correct? And absolute value. What does absolute value do? It turns all the values negative. So basically, sometimes you can describe it as everything hanging below the x-axis gets flipped over. Okay, so we're doing, in this case, it probably doesn't matter there, but we'll do the reflection first. That's what I'll do first. So what happens? All the x's get flipped over. All the x values become their opposite. I'm just going to see if I have another picture, or another pencil, sorry. Again, my pencils are... Okay, I'm trying to use this again. Okay, so all the x's, a positive 3 will become a negative 3. A positive 5 will become a negative 5 initially, right? And then a 0 stays 0, or sorry, a 0 stays 0, right? And what else happens? Yeah. Actually, sorry, maybe I'll do, I think I screwed up already. Okay, so let's do this. So I've transformed this one, I've transformed this one. Let's transform this one here. Let's transform this one. And then all of these values, this is going to stay here, right? This one's going to go here. So initially, this is what it's going to look like, right? Kind of doing in 2 steps. So this is the f minus x, or sorry, this is just, f minus x, but I'm not done yet, right? The other thing I could have done is I could have done a mapping, right? I could have done like we do, pick a couple of points and map. But absolute value, then anything hanging below is going to pop above, right? So all this section is fine. This one's going to move up here. This one will become here. This one becomes here, right? And then it's going to have another arrow. So it's going to look like this. I'm going to erase this because this is not my final answer. So this would be, and I could have picked another point, a few points as well, and done a mapping as well, right? I could have picked a couple of points and then did my reflections that way. Joanna? 1, 2, 3. yeah, what did I do here? Hang on, let me I see. Thanks, Joanna. What is everything? Yes. Sorry. That's better, right? Agreed? The other way I could have done it is just picked a couple of points of my graph, right? I could have picked maybe this one, and this one. Let's try that. And so my points could have been my XY points, if I do it this way, -2, -3, 0, -3, and then 3, 0. And if I look at here, it says all the x's become their opposite. And then all the y's, basically, I have to absolute value all the y's, right? So I could have done, that becomes a +2, that stays 0, that is -3, and then the y's become, right, all the same. So I have 2, 3, 0, 3, and -3, 0, and then just join my points that way. I could do it that way as well, right? But I have arrowheads on each end. Okay. It was harder for me than it was for you guys. Okay, so that's one of them. Another question. Let's just take a look at the question next door, because it's similar. They gave you this piece, and they wanted you to graph the root of x. So to graph the square root of a function, we find where our function had a 0, we find where a function had a 1. Yeah, and then that piece of the graph lies above the original graph, and then we find a nice value like where y = 4 and the 4 becomes 2, right? So initially it looks like she graphed everything right, except her graph should stop here. So this shouldn't be part of her answer graph, right? This part disappears. So her graph, it says, describe her error. Her graph should have ended at x = 2, right? Yeah, x = 2, y = 2, right here, and that should be the end, right? There shouldn't be an arrowhead on the end. All right. Similarly, if I look at, I'm going to do these two together because they're sort of the same style. If I look at June, the exam I gave you yesterday in book 1, so you're going to get one of these for sure. They're going to give you a picture, and you're going to either have to do square root or the absolute value or the inverse. So if I said sketch the graph of the square root, this is what they gave you. They want you to square root the graph. So once again, the square root, I can't square root a negative value. So anything hanging below the x-axis is gone. I find where y = 0 and y = 1. Those are invariant points. So that part of the new graph, the square root graph, lies above the original. And then again, 1, 2, 3, 4. Look for a nice value that you can find the square root of. And that would be the graph, right? So you're going to get some kind of picture, and they're going to ask you to do a transformation of it physically. They'll give you a physical graph, right? What if they gave you, let's try this one. What if they gave you this picture, but then they asked you to do the, I'm just going to show you this one too. I'm going to cover this up. If they gave you given f of x, okay, this is f of x, and they asked you to draw 1 over f of x. Okay, that's the reciprocal. Okay, so that's a rational function. Remember, rational functions sometimes have asymptotes. So when they give you a picture and you have to draw 1 over, you find the x-intercepts, right? Because this is where y equals 0. Where y equals 0, that's where you're going to have asymptotes. So you have an asymptote here at all the x-intercepts. And then what do? I find y values of 1, because 1 over 1. So I'm reciprocating every y value. 1 over 1 stays 1. Let's see. Where y equals 2, the new graph would have a value of 1 over 2. Where y equals 4, the new graph would have 1 over 4. Agreed? So what's happening here? I'm getting these wings, right? And because the graph, I only have one x-intercept, that's going to be an asymptote too, because this graph separates, a vertical asymptote separates your graph into positive and negative sections, right? If I only have one vertical asymptote, one of my sections is positive, one's negative. So this is the positive one, or usually. So here I've got a 1. So this is pretty much, I think, what's going to happen here, right? So if they ask you for the reciprocal function, find the x-intercepts, and that's where your asymptotes are, okay? So that's all. Those are transformations of the y equals x. What else do I have? Chris, I didn't know what time you were coming. Sorry, you're gonna have to give me a sec. Another type of question is this type, and I'm on question 11 of the June 2019.